Hi everyone. So this video is on how the packet transfer happens till the layer layer 3 of OSI model, and how the packet is or connection happens between a host from one network to another host or destination host of another network. So let's see that there is this host which has the IP address of 172.16.10.2. Let's say then the default gateway will be 172.16.10.1. There is a switch in between. Then for some hops on the routers, we get switch 2 here, and then we get the destination host. Now, like there are two protocols that are important when packet transfer usually happens, that is ICMP and ARP. So let's talk about each one of them. Okay. So so it's like ICMP is kind of like routers generally monitors the operation in the internet. So that is generally done through ICMP. So yeah. So when some things unexpected occurs during packet transfer or packet processing at a router, the event is reported back to the sender using ICMP protocol, Internet Control Message Protocol. So ICMP is also like in general it's used to test the internet, and there are multiple message types that ICMP can deliver. There can be destination unreachable, there is time exceeded, uh, there is definitely echo reply, which is used to make connection or like check if the machine is alive, and there are other ways as well. So these are some important ICMP applications that is done. Now the other protocol is ARP, which is Address Resolution Protocol. The purpose of Address Resolution Protocol is that when we look into this network, let's say we are looking into this network, and let's say that host is trying to ping or like connect with a machine which is inside that network. Let's say this machine they are connected to. So now in this case, since it is in the same network, we don't actually need IP. We only need MAC address, because NIC can connect with another um, host if it is in the same network. So what it happens is that it directly goes to the switch, and the switch so at first what happens is that the host will check in the ARP, like through the ARP protocol, that if ARP cache has the IP address, the mapping of IP address to its MAC address. If it is not, then it will broadcast that IP address message as an address resolution protocol to all the host that is present inside that network. So that can be done on the layer 2 protocol. We don't actually need layer 3 for that. So once each and every host gets that message, it checks if that IP address belongs to me or not. If that host gets that is the same IP address that they have, it will reply back with an MAC address, and that's how the host gets the IP address, and that is the purpose of address resolution protocol. So now let's talk about bit by bit how the IP protocol works and IP and packet transfer. So first is that the host uses the ICMP protocol to create echo request payload that will be on transport layer. Sorry, this will be on network layer. Since we don't need IP addresses, so that's the main reason ICMP doesn't need. So once ICMP creates the echo request payload, it hands out that payload to IP, and which creates a packet out of it. So it encapsulates the IP address which they want, or the destination IP address they want, to get the MAC address off. So now this IP layer or network layer determines whether this IP address belongs to same network or not. Okay, if it's a, let's say if it's a remote one, remote network, remote destination IP address, then the host OSI model knows that this packet is needed to be sent to default gateway which is configured on the host. So in this case the default gateway is this. So this, since it is in the same network, we actually don't need to get the IP address, and like we actually need the IP address to map it to MAC address, and we can use directly the MAC address to send that packet to the router's Ether interface. Okay, till now we actually don't need layer 3. It's all done on layer 2 protocols. Now the fourth step is, by doing this part, before that there is what I was telling about was ARP cache. So once ICMP payload is done, now the part is ARP cache. So the host will check its own ARP cache to see if the IP address of the default gateway has already been evolved to the hardware address or MAC address. So if that is there already, then just take it and like we can just do the DLL and frame it with the MAC address. So framing is done. Now the packet is on the host networks of like data link layer. Now the other case is that if hardware address on MAC address is not present, then an ARP broadcast is sent out to the local network to search for the hardware address of, or the MAC address of the default gateway, which is 172.172.16.10.1. Now the router responds and provides the MAC address of, let's say, this is Ethernet 0. So it will provide the MAC address of Ethernet 0. Now, once the packet and MAC address are there at the data link layer, so LAN driver is used to provide media access via the type of LAN being used. So LAN driver is the one where the hardware address is provided. So it is used to provide media access via the LAN, which is the connection. Now, frame is generated on the data link layer. It also encapsulates packet with relevant control informations. So till now the packet or the frame is at data link layer of the host machine. So once this frame is completed, or it is handed to physical layer, which transfers the data bit by bit to the next hop. So now here the packet leaves hosts. So now each and every device in between that receives this packet or slash bits, it will build the frame and they will run a CRC, which I'll talk about later, and checks the FCS field. Now, based on this, if the answer matches, frame is accepted. If it doesn't, frame is discarded. So for now, let's talk about the frame discarded part, where the FCS field does not match after running CRC. Then or let's talk about the accepted part. So because it's way simpler. So let's say that the frame is accepted. Now it will check for hardware destination address. Now if this matches, packet is pulled from the frame and handed to IP protocols network layer. So this happens now. This is the place where we already know that packet is on the right position, and now it will go ahead on the next part. But let's say if it doesn't matches. If it doesn't match, then the router looks up the destination IP address in its routing table. Now routing table must have this entry, which is 172.16. Let's say 20.0, which is this one, 172.16.20.0. Okay. So if routing table doesn't have any information regarding this IP address, it will directly discard this packet, and as I already said, ICMP will be created, which will send back to the originating or the sender, and it will say that the destination network is unreachable because the router is not configured. Now till here this is the case. The ninth step, let's say if router finds the entry, so router knows where to send the packet. It send that packet to the exit interface. Okay. Now let's say that this exit interface was Ethernet 1. So now this Ethernet 1 must know the hardware address or MAC address, as in the common terms, of the destination host. So it again checks the same thing. It checks the ARP cache. If the ARP cache is present, then it knows. So if it is already present, then the hardware address is handed down to the data link layer to be framed. But if the MAC address is not resolved, the reader again the ARP request is sent out on Ethernet 1 looking for the hardware address of this IP address, which is the destination. Sorry for this mistake. This will be 20.2. Okay. Now host B, or the one that is the destination address, it will respond with its own MAC address and the packet. And the destination MAC address are both sent to the DLL for framing. Okay. So that will have the router's information. Okay, which is in this part. I'll tell about how the hopping happens. So hopping is specifically on this part, which is if the router finds an entry and it sends it to the Ethernet interface. So it knows, like let's say that we were looking for 172.16.20.2, but it knows that this is being known by another router. Then it sends that, and the router receives a next router for the hopping, and it receives and it knows again. So this will happen again and again until the last router is there. Now in that router, the last router, in that last router, upon receiving the hardware address or the MAC address of the destination, DLL creates a frame with destination and source MAC address. Frame is still then handed to physical layer, which sends out the data bit by bit, and now it exits the router, the last router. Now host B or the destination receives the frame and immediately runs the CRC to check the FCS field, and it definitely the field will match, and the packet is handed to the layer, which is the network layer. Now IP receives the packet, and it after running the CRC on the IP header, if so there is CRC header as well in the IP, CRC in the IP header as well. So now CRC is run after the IP receives the packet, and if that passes or if it's correct, the IP then checks the destination address. So now this will after checking the destination address, it will still match, and finally it will come to the place of IP address, IP layer, where it have to find the protocol field for which the payload should be given to. So in this case, the checking of the machine alive is part of ICMP, which the request was sent. So the IP sends out this payload to ICMP protocol, and ICMP knows that it's an echo request as per the type of the payload, and it responds immediately. Like it first discards the packet, and it creates its own new payload with echo reply as its type. Now packet is created for as destination host as host A, and source host as host B. Now the same thing happens. This is where the loop happens, that IP then checks, sorry. So IP then checks to see whether the destination IP address is a device that is on the local LAN or a remote network. Since the destination is on a remote network, that the packet needs to be sent to the default gateway of that network. Then again, the ARP cache works where it checks whether the destination address is on the destination address of the destination MAC address of the default gateway. Once that is done, the packet reaches to the router, where it is sent back, and the same DLL frames and the FCS field is checked using this running of the CRC, and the frame is again back handed to the physical layer. The router receives, again runs the CRC and checks the field, and hops again and again until it is at the last router or the exit router. And so there are 2-3 concerns, or 2-3 main things, that if echo request is there, then If there is a problem during echo request, then ICMP will send a destination unreachable error back to the sender. But if it is a echo reply, then it will be a timeout error. Since uh, it will not be able to go back and to the sender, the original sender. Now let's say at the 12th part is that host receives this echo reply. Now it receives that frame at the data link layer. Here it runs the CRC as usual and checks the destination uh, hardware or MAC address. If that all matches, it is sent to the IP layer. So similarly, in the network layer, it checks the CRC fee, like it runs the CRC, it checks the IP address, and it then figure out like which protocol it is needed to be used for. So let's say that this in this case it's the ICMP one. So ICMP IP finds that instruction to give to the payload of ICMP, and ICMP determines which the packet to be like the type of packet is echo reply. So echo reply is identified. Once echo reply is identified, the ICMP acknowledges that it has received the reply by sending an exclamation point to the user interface. So ICMP then attempts to send 4 more echo requests to the destination host. That is the complete package of how the layer 3 protocol and everything works.